My name is Jeremy. I'm a marine biologist. I work with Coastal Impact based in Goa. And most of our work here for the past 4 or 5 years has basically focused on understanding the coral reef system that is present in Goa, and also we work on artificial reef systems and prototyping these sort of systems in Goa and understanding how we can better develop tools to monitor reefs in the west coast of India. So I'm going to start with talking a little bit about Goa initially. Most of you know Goa already. It's this state, it's a really small state on the west coast of India, and it's got two major rivers in it and a few islands around the parts of it. It's very famous for its beaches and other nice things. That's why people come to Goa. But Goa also has a lot of other wealth that people don't normally know about. Goa has a lot of wetlands and plenty of other forests. And also, Goa has coral reefs. So the reef types in Goa are classified as rocky reefs. They are not full coral reefs, but they have large patches of coral that are scattered across the entire coast. A lot of these patches are concentrated on an island complex which consists of Grand Island, St. George Island, and another small island called Pequeno. And these islands allow for small patches of very dense coral cover compared to the rest of the coastline we have here on the west coast. And you see basically that these coral grow in various patches around the island. And in Goa, on Grand Island, we have approximately 15 genera of coral that we work with here. Most of them are of the encrusting morph, so they encrust over objects and rocks and benthic substrate, hard benthic substrate. They'll attach to it and then they'll form this encrusting sort of layer over it and then slowly grow over time. The other major form that we see here is this plate or foliose form of coral, which is Turbinaria. That's the genus we work with here. And Turbinaria grows in these large flowery plates that essentially form like canopies and have spaces for fish and other creatures to interact and hide inside. And those are the two kind of main forms we see in Goa. We do not, unfortunately, we do not have any branching coral that we can see today in Goa. Talking about some of the work that has happened in Goa, we started working here since 2019 on mainly Turbinaria and slowly other species of coral as well, and monitoring the reef in that regard. There have been other teams of people from NIO, other organizations, and even NGOs who have worked on various aspects of the reef, so diversity, disease, biomass, things like that. So there's still a lot of scope to finally understand the details of the species we're working with. In fact, we don't even know for sure what species we have here. That is still something that is in the pipeline. We are in the process of trying to use molecular taxonomic techniques to understand exactly which species we have present here. As I was saying, we look at about 15 genera of coral that we find here. Every piece of work that has to happen with the forest, with coral in Goa has to go through the forest department. So we've been working very closely with them. And one of the main reasons we're so interested in a system like this, despite the challenges which I will talk about in a second, but one of the reasons we're so interested in a system like this is because Goa's waters present very harsh conditions for what you would normally think a coral could tolerate. So these corals actually grow in very high sediment loads, very high nutrient levels, and they survive. Every year they bleach, but they survive. And that to us shows that they are probably capable of some high level of resilience. So that is one of the reasons we think studying coral like this at this stage is very critical to coral science just globally, because in the trends that follow in the next couple of years, things are only going to get more dire. So about the reef in Goa, like I was saying, it is a rocky reef. The main substrate of the reef is rocks and boulders, and hard substrate, and coral forms a layer on top of that. So coral can sometimes consolidate that substrate. So if you have small rocks, you have coral growing over it that then forms a layer over those rocks and binds them together. Or you can also have coral making those plates like I spoke about earlier. And yeah, so that's those are characteristic features of a rocky reef where the rock is the main substrate, not the coral, right? The other thing about Goan reefs is it's extremely highly sedimented reefs. So if you see, this here is the island that I was talking about earlier, Grand Island, and it's situated at the mouth of two of Goa's biggest rivers, the Zuari and the Mandovi. So right as the Zuari and the Mandovi open up into their deltas, there's a lot of wind and a lot of water activity that can drive all of that sediment southward, which ends up on the island. And the island is extremely close to shore. At its like closest point, maybe about 4 kilometers from shore. Basically, that all those factors combined ensure that we have a lot of challenges when we do any sort of work in Goa. One of our main challenges is we deal with extremely low visibility. Visibility in Goa, for those of you who are into diving, ranges all the way from zero, where you can't see anything, to about 10 to 12 meters on a very good day, right? The average visibility in Goa is about 5 meters, which is enough to do a lot of good work, but it's very dicey. Sometimes, if you're in the middle of a collection or a sampling session, or you need to do some sort of monitoring, you go down there and the conditions are not right. And these are not conditions we can pre plan for because they're highly dependent on tides, winds, rains. The wind can change and the visibility can just turn. So it is a challenge working in the system, and we've had to modify certain methods we use to gain certain amount of data in this system. We only get 6 to 7 months of field time on a good year because of the monsoon in the western monsoon winds. The ocean on the west coast is extremely choppy. Even if it's not raining, the winds are so high that the waves basically, the sediment goes all up in the water column and visibility is almost always zero. That, coupled with the dangers of going out at sea in those disturbed conditions, basically means that the entirety of monsoons is a no field time zone, which means we severely lack any sort of data for the entirety of the monsoon period. The stressors on the reef are extremely hard to mitigate for. So whenever you're talking about coral restoration, whenever you're talking about any sort of a format, any sort of action to tackle any of the issues in a system, it has to be very context specific. And the first principle is reduction. So you want to get rid of what your main stressors are. Unfortunately for us, that is something, as scientists, as an organization, it is very hard for us to tackle singularly, right? That's not something we can do through a project. It has to be an over-encompassing effort to curb pollution, to curb temperature, and those sort of things take time. So we tend to focus more on our research actions. Coastal Bank, very small team. It's essentially Venkat, who's the founder trustee. He was a banker turned diver, dive instructor, ran a diving center in Goa for many years, still does. But in 2009, he decided to start the organization because he wanted to give back to the ocean, and it sort of hit him on a personal note, and this is the product of that essentially. We started our work in 2009, but at that point it was mainly outreach programs and awareness programs for children and other people. Roanna is a marine biologist, a marine microbiologist, and most of her work revolves around trying to understand coral and what kind of things affect it. And she was instrumental in setting up the first coral project that Coastal Impact took on under the Habitats Trust in 2019. I am a dive master, a scientific diver, and ecologist. And I am also very keen about how I can use research diving techniques and data collection with integrate that into sort of tech to make life easier for everybody. That's where I bring my expertise in. So, coastal impact, we work in three sort of areas, mainly conservation, education, and research. Our education is more about going and talking to communities, people, children, and spreading awareness. Research is when we do conservation projects, we aim to understand a lot of things about the system we're working with and the kind of animals or organisms we deal with when we do these projects. And conservation projects are just what is our bread and butter. We have a few which I'll get to in a second, but essentially those projects lay the groundwork for us doing all of our research and understanding these systems. So, yeah, so I'll just break down some of our work. So marine awareness, we have a program that we run called the Marine Awareness Program, or MAP, where we go and talk to various people, mainly school children. So we're looking at Goan school children all the way from class 7 to class 12, which we think is a good target age group to kind of make them understand that they have an important resource right in their backyard that most people don't even know. Most people don't know you get coral at all in Goa, period. Right? So this is something that we find it very important to sort of get that message across, that this, hey, this is something you have in your own backyard. It's very important. This is what is happening to it. And, you know, if this continues like this, it's not going to be there anymore. So making these children understand that there is something there and they can establish a relationship with the ocean, I think is a very important part of any sort of scientific project. And every bit of science that all of us do needs to be communicated to the next generation. It's of vital importance. Another thing we do is every year we go to the island and we tend to take a set of school children from various schools, a few scientists, and people from different aspects of life that we interact with, and we take them to the island and we do a beach cleanup on the island, as well as simultaneously we get the divers to do a cleanup underwater. So every year we collect about 400 to 500 kilos of trash. Last year we collected about 460 kilos of waste, which was then sent to a Margao recycling plant. We recycle, I believe. And that forms basically our major interactions. We give these presentations to people who are school children, but not just limited to that. There's corporates that we've done it for. There's government bodies like the fisheries and the forest department. So this is for anybody who wants it, and this is free of cost. We don't really charge anybody. Our first activity, our first project that I was talking about is where we established a coral nursery using the using the THT grant. So the Habitats Trust was the first organization to sponsor Coastal Impact with a grant in 2019, and that helped us set up the coral nursery. What the coral nursery essentially is these beds. So we fabricate these really low cost temporary structures made of metal. So these metallic frames, and to these frames we attach flooring tiles. So we go to tile shops and get donated flooring tiles to us, and essentially utilize those tiles as hard substrate for the coral to grow. So ceramic is really good for growth for many creatures underwater, and flooring tiles, especially wastage tiles that are lying in a go down with which they don't make anymore, they're chipped, whatever, we can still utilize those, right? So I think one of the best utility for something like that is using that as hard substrate underwater for these coral. And this is how it starts out. We collect fragments of coral from the natural reef. So as part of this restoration project, in fact, as part of all our restoration projects, we don't touch any live coral that is attached to the reef and break it off the reef to get a mother colony and move from there onward. So that's not the process we use here. Goa has a very high number of naturally broken fragments because of its extreme monsoon season. Normally post monsoon on every reef, you'll find a ton of broken coral fragments that are buried in the sand or rolling around in the sand. And if they continue to do so, there's a good chance that they get covered up by the sand and die. So what we do is we pick up those fragments, give them a little time to recover. We cut them up into smaller bits, maybe about 2 to 4 cm square, tiny little bits underwater itself, and we take them to the transplant site, and we affix them to these tiles using epoxy. So we have a marine safe epoxy that we use. So over time, the coral essentially sticks and starts growing onto the hard substrate, right? And then it starts growing. So I can show you, sorry, I can show you here. I don't know if you can see this, but this was likely the original size of the fragment. And then this is the growth that the fragment reaches. And you see there's a high level of sedimentation. So these tiles have to be cleaned every so often. So we actually run a program called the Adopt a Coral program that helps us bear the costs of taking out a boat to go and clean the coral nursery. So people can adopt corals. We send them a picture of the coral. We send them a picture of the size every time we go and measure. And then we also basically utilize those funds to clean these tables. All right. So when we did this coral project in 2020, 2019, 2021, we noticed that a lot of creatures started living on these structures. Plenty of fish, stingrays, other organisms, cuttlefish. There's just any number of creatures were just showing up and utilizing these tables as homes. So we thought, hey, this actually works as a pretty decent artificial reef. Let's explore that dimension. Let's explore if we can also, while measuring coral growth and providing a place for the coral to grow, let's look at how we can also make it better for the fish. So with that, we started our next project called the Artificial Reef Structure Project, and this was sponsored by HPCL, Hindustan Petroleum. And essentially it's the same principle, except the table now is a three-dimensional structure, which provides more holes and more entryways, more shading for these marine organisms to enter and exit. And that's what we rolled with. We transplanted these structures to various sites across the island. So there were 4 sites, and we utilized this opportunity to test comparative changes, like if there was any growth differences or other differences in transplanted coral at various sites. We also started testing out using the encrusting coral instead. So the encrusting coral, the fragments are much, much rarer than table coral fragments. So the turbinaria I was talking about earlier breaks off very easily. These guys don't break off very easily. But you do find rocks that are not attached to substrate, free floating and rolling in the sand. So we find those rocks. They're about the size of a fist, maybe, but generally smaller than that. And then you plant these onto hard substrate, and then the coral can extend onto that hard substrate essentially. So that's another form of restoration we started looking at. Back to the artificial reef project, we placed the artificial reefs at various sites across the island. Some sites we placed it to the north of the already established, like the rocky reef. Some sites we placed it to the south of the reef. Some sites we found where the reef was bowl-like, where you'd have sand in the middle and rocks around where the reef would support that. So we tried placing it there as well, and then we tried placing the remaining structures on an entirely open sand space. So this is what the metal frame looks like for the artificial reef structure, and this is what the tiles put onto that structure look like. So we utilized these tiles, we planted coral on them, and we were looking at a couple of things. So after coral grew, right, all the earlier projects, when we first started the nursery, we were measuring coral using vernier calipers. So we would measure coral by hand. As we scaled up, that became a problem. So we developed this sort of method where we would use a reference object, which is what this white square that you can see here. So we would use a reference object of known dimensions and click pictures of each tile. Then we would essentially take those, make sure that they are fixed dimensions, and we would count the number of pixels. I mean, not physically, but the computer would count the number of pixels inside this object, and we would annotate the target object. So we would start annotating these corals, basically draw lines around them, and then the program would tell us, based on the amount of pixels in this little white square, how many pixels are in this coral. So that's the method we use to extrapolate planar area, so surface area of the corals, and that's what we can use for growth. So this method actually worked really well for us, because remember, we don't have any branching coral in Goa. We only have encrusting, which forms a flat crust, and we only have table coral, which also grows fairly flat, especially when it's in its younger stages. So this worked out really well for us. Planar area seemed like a very good metric, and it still is a very good metric. Um, so we started here. So as you can see, this is the fragment of Cyphastria. Started around 2.2 cm square, and in 6 months, it has grown to about 33 cm square. That's an astronomical amount of growth in just 6 months. But this is a fast-growing species. These are some insights from the data which we're still disentangling currently. It's finished processing, but we have to do some analysis on it. But essentially, these are what fragments. So all of these are turbinaria, except the last one, that's Cosenaria. But all of these are turbinaria, and you can see how over time these coral sort of grow, and the purple masks can show you the exact area that that coral covers. There are other species we worked with, like I said, as well, the encrusting species, the favids, the Cyphastria. And you can see over time how these numbers change from around 3 to 4 cm square to a good 20, 25, 26 cm square average. Coral growth rates are highly variable even within the same species, which is something we're trying to figure out exactly why. But soon we're going to have growth models for all of the different genera we work with in Goa. The structures worked extremely well, as you know, as intended. Fish started nesting on it. They laid eggs. So cephalopods used to lay eggs on it. The fish started nesting under it in the sand. The juvenile batfish were using it as homes, essentially. The puffers were using it for nesting. So a plethora of fish basically came to the structures, and it worked pretty much as intended. They were feeding off the algae that grew on it. There were a lot of invertebrates, nudibranchs, urchins. So it came with its own biota, essentially. Ascidians, sponges, all of these things started recruiting onto these structures. The last thing we kind of do in as one of our activities is we conduct surveys. We've just started a permanent monitoring program of the island now, where we choose a bunch of sites and we try and quantify what kind of diversity, what kind of benthic diversity is present, and also at the same time look at fish as a dimension as well. We do fish assemblages, and we're trying to automate some of that right now, because right now it's in a very manual stage, and everybody does a lot of this manually, and it needs a trained eye. You need to have someone who can recognize coral, recognize features underwater, recognize even species. So currently the barrier for entry is a little high to even process this data. So we're trying to make it super easy to process by automating some of these systems. There are tools we can use online like CoralNet and things like that for point annotation and benthic annotation, which is something that we've been working on and something we would like to work on in the future as well. I'm not going to get into this in too detail, but basically we're trying to use image detection to make our quadrats easier to see and automate. I'll just quickly recap some of the key research findings that we see in Goa. So the corals here have evolved like over multiple generations and thousands of years to live in riverine conditions, like very close to rivers. River mouths means a lot of stability, a lot of sediment, and these guys grow really well in there. So we know that they have some sort of resilience to these factors, at least, right? They have survived multiple bleaching events, and they continue to do so. Every year the reef bleaches, every year it comes back, and that is something we're monitoring as well. And so they're likely candidates for super coral. Super coral is something that is what Superman is to a human, a super coral is to most corals, right? Some of our future things that we want to look at, which unfortunately we haven't started on yet, but we have proposed, is we want to start moving away from using two-dimensional surface area to measure corals now, and we have been experimenting with using three-dimensional volumetric estimations using photogrammetry. So you can take an object underwater, and then you use a scale, and then you capture multiple angles of the object, and you can recreate that fairly well in 3D using a point cloud, and then you estimate the volume of that object. And this is used to basically look at coral growth over time. So that is sort of um, the next notch in our belt. We want to use that method and develop a complete methodology for estimating coral growth on a natural reef or on an artificial reef in 3 dimensions. But yeah, that's about it. Thank you so much. If you have any questions, now would be the time.